This is the data collection demonstration video for the Electric Field Lab of Physics and Engineering 217. In this lab, we're going to be examining several different configurations of metal shapes. These are all shown on the right-hand side there. And for each of these, we're going to apply a potential difference to these configurations, where we'll put some high voltage to the shape on the left, and the shape on the right will hold at 0 volts, or ground. For each of these configurations, once we have the potential difference applied, we're going to perform a scan on these configurations where we're going to measure the voltage at a number of different locations. From that scan data, your team will be tasked with calculating what the electric field is given the voltage measurements that we took. So what we mean by a scan is if we pop over here and we imagine this grid of points overlaid on one of these configurations shown here. What we're going to do is use the CNC with a voltage probe attached to the end to move to each of these different scan points, each of these different grid points shown here, and we're going to measure the voltage at each and every one of these points. And this data, we'll write this out to a CSV file, and that's what you're going to use to perform this analysis with. So we'll provide some other data as well. We'll include some images and some configuration information, but this CSV information of these voltages measured at these different scan locations, this is what you'll be using to perform your analysis. So now that we've kind of covered the broad overview of what we're going to do for the data collection, we can actually take a look at the physical equipment that we'll be using for this lab.
So we'll start off for this lab going over the equipment and setup that we have available here. So to start, we'll show this metal piece that we have in the center here. So this is a metal frame that's been attached down to the air table so it won't move in the course of our experiment. And in this frame, in this center region, we have a piece of conductive paper. So this is an electrical conductor that we'll be fixing these different shapes to for the different configurations outlined in the lab manual, and holding them in place, and that's what we'll be performing the experiment on. Those particular shapes we have here to create our configuration are these. These are just different aluminum cutout shapes that we'll be able to place over on our surface here and hold in place with some magnets that we have, so they'll stay stationary throughout the course of the scan. So this frame is what we have to hold the shapes. We have the shapes themselves, and we'll want to apply some voltage to this so we have a potential difference that we'll be able to measure. So to supply our voltage, we of course have our power supply here. For our purposes in this experiment today, we'll be using the channel 2 that we're connected up here. And we just have normal banana plugs plugged in on this end. However, on the other end over here, we have these little magnet ends on our banana cable. And the advantage of that is we can then stick these down to our surface. So that way we know we're applying the voltage directly to those shapes and they won't accidentally slide around during the course of our experiment and not make contact or something like that. Lastly, back here, attached to the CNC in this corner, we have a voltage probe. And so as a close-up view, we have another one here. Here's what the voltage probe itself looks like. And so this voltage probe, we have this little tip on here. What we'll do throughout the course of the experiment is we'll scan this across the conductive paper, and where this probe tip is making contact, we're able to make voltage measurements there. So we can move the CNC into the desired position, take a voltage measurement, and then move on to the next place to perform our scan. So as kind of an overview there, we have our conductive paper frame here that we'll be attaching these different shapes to with magnets. We'll apply a potential difference to those shapes with our power supply, and then we can measure the voltage at various points using the CNC with our voltage probe attached to it. So now we're going to actually set up and perform one of our scans here. So we're going to start off with the configuration A as outlined in the lab manual, where we have the sharp point on the left and the straight bar over on the right hand side here. And what we'll be doing, since we've already have these attached down to our conductive surface with those magnets, those white and black magnets that you may see there, we'll want to attach our power supply to this. So we already have our power supply on over here, and we're connected up to channel 2. So on channel 2, we'll set our voltage to 10 volts, and we'll keep that constant across all the scans. We'll use the same voltage here. And for the current, we'll set that to a max of 0.1 amps, just for safety's sake. So coming back over to our shapes, And again, for the sake of uniformity, we'll keep this convention the same for all of our scans, but we'll be applying the positive voltage to the shape on the left, and we'll apply our ground, the black side, to the shape on the right there. So now that we have those attached, we can come back over and we'll turn our power supply on. So now that we have our physical setup ready to go here, we can pop back over to our terminal and we'll take a look at the software that we'll be using to perform this scan here. So as per usual, we'll take a look in our examples directory. And inside this, we have this scanning subdirectory, which is what we'll be taking a look at here. So we have a number of different scripts for performing scans in here, and the one we're going to be interested in for this lab will be this runvoltscan.py script. So since we'll want to open that up and maybe modify some of the parameters in that script, we'll make a copy out in our home directory. So if we list out the contents of our home directory, we see it there, so it's successfully copied. So now we'll open up that script with a text editor here. And we'll take a look at some of the parameters that we have to play with. So there's a lot going on in this code, but what we're going to be taking a look at here will be this just program variables section here in this scanner quarks dictionary. So these are just all the different parameters and settings that we can set within this code to determine how our scan is going to run. So this first one that we have here, file name, as the comment says, this is just what we're going to be calling the output that we get from this script, which will be an image and a CSV. So since we're running configuration A here, why don't we give it a descriptive name like configuration A. These next two, the X center and Y center, as the comments indicate, are the center of the region we're going to scan. So for this scan, we're going to be looking at a grid of points. So we'll take a reading there, down another row there, etc. in some sort of rectangular shape. So the center of that region, the way we have things set up here, we'd want something right around here-ish, right near the tip of that. So the way we're going to measure that is it's going to be the millimeters, as the units say on the code comment there, from the origin of where our probe is. So that's going to be over here in the CNC home position. So the CNC x-axis is along this direction and the CNC y-axis is along this direction. So if we take our measurement for x from where we have the probe centered to that halfway point here, looks like that's 390 millimeters. And then if we perform that same measurement from the center of the region this way to where we have the probe centered, it looks like if we do it that way, we're about 460 millimeters. So we'll come down here in the code and we'll get those two values entered in here. So for our X center, we'll put 390 millimeters, and for our Y center, we'll do 460 millimeters. So the step size is going to be how far apart each of those points in our scan grid is here. So if we had a large step size, we might take a reading here, 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 and if we had a small step size, we might take smaller increments as we go. So this default value here of 25.4 millimeters, that's approximately an inch. We're going to want some finer detail than that, so I think for our scan here today, we're going to step this down to 7.5 millimeters. These next pair of parameters that we have here, X steps and Y steps, these are going to be how many steps in each of these two directions that we're going to move. So if we had X steps set to 3, we would take 1, 2, 3, and Y steps 1, 2, 3, for example. But again, that's not very high, and since we have a small step size and we want to cover this whole region here, we're going to use a bigger step size. So for our X, we're going to set that to 20, and for our Y steps, we'll go ahead and set that to 30. All of these values that we use for each scan, we'll make sure that we include in the final data, just so you know what parameters we're using for each scan. Then lastly, we have the velocity. That's how fast the CNC is actually going to move when performing this scan. This 40 value isn't bad. We'll step it down just a little bit in order to prevent any kind of jitters going on when performing the scan, just to make sure we get a nice high resolution image. So now we'll save out our changes and clear up our workspace. Now we can go ahead and actually run that piece of code. So as per usual, it's just Python 3, then the name of the script we want to run. So when we start that script, the first thing it's going to do is find that home position for the CNC. Then it's going to move to that center region that we specified in the code. And just double check that that's where we want to be and make sure that the probe height is adjusted. If we come down here a little bit, you might be able to see that we're just barely making contact with the paper. If we weren't making contact, we're not going to be able to measure any voltages. So we're just checking here that we're actually making contact with the paper, and we are, and everything looks good. So we'll go ahead and hit enter to start our scan. So it's going to move over and then just start taking readings. So over on the terminal, it's printing out some values, and what those are the CNC coordinates. So we have an X and a Y for millimeters for the CNC location, and then that voltage value is just whatever our probe is reading at that location. And as you would expect, if we take a look at this on the left-hand side when we're near our point, we have values about 10 volts. And when we travel to the right-hand side near that straight bar, which we have grounded, we see about 0. So this data is making sense for what we would expect to see. So we'll let this go about and perform its scan. Depending on what the different parameters we have included there for step size, number of steps, and velocity, this could end up taking a couple minutes, or it may be a fairly short scan. So we'll let this go ahead and run here. Great, so it looks like our scan's finished up here. The CNC is returned to its home position. It prints out the total time that it took to perform that scan out on the terminal, and it shows that it's press enter to save, plot, and quit. So while that's occurring, up on screen here, we're actually displaying a heat map plot of those different voltages that were measured throughout the course of the scan. So this is just a one-to-one mapping, essentially, of what we took. So for each of these are a different scan location from the CNC, and the color there is going to represent what the voltage measured at that point was. So we'll hit enter to end that. And now if we list out the contents on our home directory here, you'll see we have 2 new files. So one is a configuration.a.png, and what that is simply a copy of that heat map that we showed up on screen. The other item we have here is a configuration_a.csv, and what that is a CSV containing those raw voltage measurements that we took in order to produce that scan and plot that we saw up on screen. So for each scan that we perform, we're going to include 4 pieces of data for you. One will be the CSV produced here, one will be the PNG produced here, one will be a copy of those different scanner quargs that we set in the code, just so you know what parameters we used. And then we'll also include just a photo of the physical setup here, just so you know what it actually looks like in terms of the actual physical setup that each of these different scans align with. So those are the 4 pieces of data that we'll provide for each of these. We won't show each scan on screen here, just since it does take, as the terminal shows here, about 4 minutes a scan, and we don't need that video to be that long. But we'll perform the exact same procedure we did here, and we'll provide you those 4 pieces of information for each scan that you can use for the analysis.